Okay, we'll look at some of the homework problems that are in section 5.4. And we'll start with problem number 1 where you're asked to test whether the number 165 is prime. And by definition of a prime number is that you only have two factors, the number itself and 1. Now in this case here for 165, this would not be a prime number because I can look at the last digit in 165, and that's a 5. That tells me that 165 is divisible by 5. So here, no, this would not be prime. 165 is not a prime number. Number 2 is to find the prime factorization of 980. And they want you to type the answer in factored form. Now, one way of coming up with the prime factorization for the number 980 is to create a factor tree. And what we do here, we start off with two numbers that will give me 980. Well, by looking at this, 980, the last digit is a 0, so that means that number is divisible by 10, so I'll start off with 10 times 98. Now, 10 is not prime and 98 is not prime, so I continue the tree until I get nothing but prime numbers. For 10, it'll be 5 times 2. And 5 is prime and 2 is prime. So what I would do is circle those prime numbers. And then break 98 up into, let's say, 2 times 49. Because I know 98 is divisible by 2. And again, 2 is prime, so I'll circle that. Now 49 can be broken up into two numbers, 7 times 7. And 7 is prime, so I'll go ahead and circle both of the 7s. So here, those circled digits are the prime factorization for the number 980. Now keep in mind, for a prime factorization, you must have a product of only prime numbers. So if I put this in numerical order, the prime factorization of 980 would be 2 times 2 times 5 times 7 times 7. That's how they want you to type in your answer in factored form, as this. Now problem number 3, they want you to fill in the missing numbers in the given factor tree. Okay, so here we're going to have to start from the bottom and go upward. Well, if we multiply 7 times 2, we can come up with the number that's for this box here, which will be 14. And then multiply 14 times 2 to come up with this number here, which will be 28. And then finally, if you do 7 times 28, we'll get the top number that we were getting the prime factorization for, and that's 196. So with this factor tree, you have to start from the bottom and work upward. All right, the next problem, problem number 4, is finding the greatest prime that you must consider to test whether 4,749 is prime. So we want to find out what will be the greatest prime that we must consider. There is a rule that helps us determine what is the largest prime number we can use. Here, the prime number, which we're going to call P, has to be less than or equal to the square root of n. And n is the number that we're dealing with. And in this case, it'll be 4,749. So here, our prime number must be less than or equal to the square root of 4,749. And we can use the calculator to calculate the square root of 4,749, which will be 68.9, or rounded to the nearest whole number will be 69. But keep in mind, 69 is not a prime number, because 3 times 23 will give me 69. The largest prime number that you have to consider that's less than 69 will have to be 67. Because 67 is prime, and it's less than 69. So the greatest prime number that we can consider will have to be 67. It's just a matter of knowing what your prime numbers are. If you remember the Siva Eratosthenes on the Wimber presentation, you'll see that 67 is one of those prime numbers. And then, number 5, explain why 22 to the 4th times 26 times 25 to the 13th is not a prime factorization, and we want to find the prime factorization of the number. So, let's answer the first part. Why isn't 22 to the 4th times 26 times 25 to the 13th a prime factorization? Well, by definition of a prime factorization, it is nothing but a product of only prime numbers. And if you look at this, 22 is not prime, 26 is not prime, and 25 is not prime. Okay? So here, in this case, we have to say that the factors are not all prime numbers, which is in this case answer D. And then next you're going to choose the correct factorization. Okay, let's take that 22 to the 4th that we have times 26 times 25 to the 13th. Now 22 can be broken up into 2 times 11. So now that 2 times 11 in the parentheses will be to the 4th power. 26 can be broken up into 2 times 13. And 25 can be broken up into 5 times 5. And that's going to be raised to the 13th power. Now, keep in mind that everything in the parentheses is to the 4th power, so that 2 is to the 4th power, and the 11 is to the 4th power. And then we bring down the 2 times 13 times. Now, 5 is going to be to the 13th power, and again, this other 5 is going to be to the 13th power. Now, let's simplify this a bit. There is a rule that says when you multiply powers of the same base, you're going to add the exponents. So if I do 2 to the 4th times 2 to the 1, if I add the exponents for 2, it will be 2 to the 5th. And I'll do the same thing for the 5. 5 to the 13 times 5 to the 13, add the exponents for 5, you'll have 5 to the 26. Times, and then 11 to the 4th, times 13. So in this case here, to choose the correct answer here, we would choose, and if I can find it, answer D. 2 to the 5th times 5 to the 26 times 11 to the 4th times 13. That would be the correct factorization that we're looking for. Okay, so that should be enough to assist you with the homework problems that are on the MyMathLab.